Oh, we did, yeah, okay. Okay, well, hi, everybody. So I'm Darek Kominek from Matrikon. We're a Honeywell company, but we're a standalone brand, so just to get that out there. Matrikon is, we actually have kind of a foot in both boats. We provide a user-facing product, so we enterprise-wide connectivity for sort of the things that Stefan was talking about as far as facilitating data going all the way from shop floor, everything to the firewalls, DMZs, et cetera, and talking up to the cloud. At the same time, we also actually build the toolkits toolkit that we use for developing the software. So let's say we dog food it, we use what we build. Now, in this case, we also partnered, our strategic partner is BE.services as well. Melvin couldn't join us at this presentation, so I'll run through the presentation. But basically, we'll be talking about an offering that lets you develop a solution that includes both the TSN component and the OPC UA, basically the FX brought together. So I'll describe some of that, some of the things. So everybody's done this. I thought, the technical lists of which spec does what. So just overall, we're talking about, let's say, the three different levels. We've got the devices and controllers. We have shop floor in general, where the operations, the OT happens, and then IT and cloud. And of course, just yet another way to show it. But when we look at what OPC UA gives you, in a more sort of a simplified way, basically you've got the pub sub MQTT typically is well tuned primarily for when you're talking to the IT and the cloud side. Yes, it goes across sort of all the levels, so you can use pub sub all over. But there's that one. There's the client server that everything started with, and then we have the UA pub sub UDP, primarily living in the dev and control. So one of the things that I really like, that the fact that it really does extend OPC UA going down, because while we continue to use the same infrastructure, as everybody already said, and it lets you use the same semantics and everything else that we've been doing for years now, 20 years plus, at the same time we're adding the real-time determinism and such. So when we zoom in on UAFX, there are certain use cases that, of course, you see. So when you go right down to it, sort of the fastest way, when you're starting to use robotics or motion control and such, things really get fast, right? So you got the controller to device type communications. At least that's the level we're talking about now. So we're talking down in the levels of 250 microsecond type timings in order to actually operate and work between various robots and such. So closed loop control, jitter is extremely important too. You obviously have to have stable communications. So we're talking in the range of, it needs to stay below, let's say, 10 microseconds. Obviously a way different world than what OPC started with when you're in the 1 second type of range, right? Also, there's controller to controller. So again, this is where we would use UA pub sub again over UDP, rather than the raw Ethernet, which just gets even faster, right, that below. Here, whether we're talking about 1 millisecond, which now sounds a little slower, and it's still way faster than what we did with client server before. But that's, this is where you're doing real-time operational insights, condition monitoring and such. And then we also have, of course, the functionality for client server. You're basically, primarily when we look at UAFX, what we're doing is things like configuration and just SCADA monitoring and such. It's also a great way to tap into. So for example, for us, again, as I said, you might have a toolkit that's used obviously to implement all of this, but then you want that handoff. And again, as some of the presenters mentioned before, you don't need to change the semantics, you don't need to manipulate the data structures to then go into sort of the OT shop floor stuff. It's just all there, right? So for example, our product like Data Broker just automatically picks that up and makes it available enterprise-wide. And of course, we also have the cloud, super important, outside the scope of what UAFX does, but absolutely a component. And again, same story, you're representing the information the same way throughout, right? So then you're doing all your fancy applications and all the scalability that's necessary. So that's really a great thing. One thing that I really enjoy about UA when we look at that, you can present information in different views. So this is a little bit of an aside, but the fact that, on the left there I show various variable types, how you want to present it applications that are using it for doing predictive analytics or whatever else they're doing in the cloud, they might have a different perspective or need than what you're doing when you're monitoring the actual operations down in the shop floor. Same data could be presented a different way. Everyone has access to all the different views. So that modeling aspect of UA and the ability to map it is, really fantastic when you're talking about especially like the integration aspect. Okay, so I'm going to just touch on two sort of things that I think are, challenges, let's say, in the implementation journey. So number one, when you start trying to create high-speed communications when you're using UA, really you have to deal with a number of things. First of all, things get smaller, and because of course you're trying to, as vendors, when we work with vendors, they're trying to minimize the costs, right? You don't want to over-engineer it, so you're going for the smallest microprocessor that'll still have a good, lifespan for the product, but you're trying to use a much smaller board, right? So you have resource-constrained environments, less and less RAM, the microprocessors, they're getting more powerful, but still, we're also asking more of them, and therefore you have to make that as small as you can, right? There are different OSs that you have to deal with. And then there's also a question of tool change. So again, what UAFX brings in, if a vendor has various product lines and you've got all sorts of devices and sensors and everything else that you're going, hey, geez, this could also talk the same way, well, they're not all going to be built on the same board, because obviously they get smaller and smaller, cost levels are different. So really the challenge is to find toolkits, for example, that will enable you to minimize how many different tool chains you have to learn and how many times you have to switch over, because obviously that is way easier on the development teams, and just the overall tech debt is much different. So that is an essential aspect when you're looking at implementing OPC UA down at these levels. It's a more complex environment that way. And then there's, of course, just OPC UA itself. It's a large standard. It's robust. It's very capable. You don't have to implement all of it, but you do have to understand which pieces of it to use for which things you're trying to create. So when you have toolkits that are designed specifically to help you with how you implement UAFX, or basically for these smaller environments, it strips away the things you don't necessarily need for the things and keeps the things that you do. And therefore you're trying to reach that parity between how big is the toolkit and what's the footprint of it, and what is the functionality you actually need for that type of device, rather than a theoretical approach to, well, you could want to use it, et cetera, right? So you want to balance that. So that's challenge number one. Then the second challenge, of course, when you start getting into TSN, you have to understand that. So I really enjoyed your slide where you showed the whole, spectrum of all the different 802.1 standards. I don't know all of them. I don't deep dive that far into it. But the key thing is that you have to know which pieces you could remove in order to still have a correctly functioning as specified component that's going to plug in and work with all the other vendors' systems. And you have to then, of course, know how to implement that. And there's a key one there that I put at the bottom, because again, it's very important. Dealing with jitter and latency, these are essential things when you're talking about these high-speed communications. So if someone is starting their journey and they're trying to implement that, between challenge number one plus challenge number two, when you're actually dealing with, a proper implementation of TSN, that's a lot to ask of a development team, especially if they haven't been working with that. So again, when you look at what would be ideal, at least this is the approach we took when we partnered with BE.services, is that we're experts in OPC UA, so are they, but the thing is they also have a very strong background in the embedded space and also TSN. So creating a toolkit that combines those two, and you have an engineered solution that combines both what are requirements in UA and brings together TSN, that gives you a starting point as a vendor to say, hey, now you can basically use this single unit, which you can deploy and start to build the environment. So simplifying the UAFX adoption lifecycle, that's sort of what we focused on. That we thought that was the key thing to do. Of course, you have to check all the check boxes for what's required to implement the product, but that's what's needed. So the plan for that, or at least the recommendation, would be number one, definitely leverage toolkits, because it takes a long time to build these things up from scratch. You also I think can gain a lot by looking at integrated solutions that actually bring both the TSN and the OPC UA aspect together, because you get a two-in-one sort of optimized setup. Number two, it's extremely important to not forget about training. Okay, a lot of times when people start this, you don't just get a toolkit and now you suddenly know how to use it. It has a lot of capability, but you really have to understand how does it actually behave. So whether that is people still just starting off in OPC UA and understanding that, or getting deeper into the inner workings of how you implement that, both on, so the toolkit that we have is called eFlex for embedded flex, which is, let's say, the companion specification, or toolkit. I hinted too much companion specs. Is the toolkit for either the application side or eFlex for embedded applications, and eTSN, which BE.services provides, is basically the other side of that, the embedded TSN stack. Okay, so getting training on that is very important, because whether you're going to get somebody else to build that component for you, or you're implementing it, later on you also have to maintain it. So training is extremely important. And then the third one is, depending on what your go-to-market is and how quickly you're trying to do that, consulting is another option too, right? So having expert developers who live and breathe TSN and embedded applications absolutely can spring you forward for what you're trying to do with the products. At the same time, having your team trained up so that they can take over and extend and continue on as the projects continue. That's another way to sort of parallelize both the learning aspect, but also the ability to go to market. So that's the approach we took there. Okay, so I just thought to give you a visual of what the difference is between trying to take different toolkits or try to figure out how to kind of wangle everything together to make it run when you're just getting started, or taking something that's fully integrated and basically you're going to run it. That's sort of the visual. By the way, it took a long time to find a guy using a motorbike in the forest, but where there's yeah, he's not crashing. So it's, I mean, you eventually get there. So it's not that you're going to fail. It's just when are you going to get to the finish line? But yeah, where there's a will, there's a way. Anyhow, so that's just a little bit of a view. So when we look at the professional SDK that we are providing together, again, collaboratively with BE, there are different parts of it, but just to identify some of the extensions that were mentioned. So as the motion, safety, and et cetera standards are coming out, they will layer on top of that. And again, they are independent of what the underlying stacks are. But basically, we are providing the OPC UA know-how or the capability with the eFlex, and eTSN actually already incorporates eFlex into it. It's built on top of that. So again, engineered solution to provide sort of a holistic approach to doing this. Again, I think there's a lot of detail you can dive into in UAFX, but at the same time, in the end, if I was a product manager, I would say, great, love the details, but when am I going to get to market, and can I rely on it, and what's the quality? So our goal on this is get to market as fast as you can. That's what drives adoption. People need to see this stuff to believe it. Okay, so speaking of believing, we've already had a few demos working again with BE. So this video was actually taken at one of their the booth. We made it that they actually have a Neura robot. We're using BNR controller and a BNR TSN switch. We also had PowerLink. And the idea is that you start taking the traffic, and we were using UAFX, or basically UA over TSN, in order to translate between them and ferry the information back and forth. And this was done in real time, actually running the robot itself. So this is something that's, like in practice, physically moving. Now, a few key things to look at, and this is when you were mentioning also the bringing in video, or when you're working with various streams. That's extremely important. When we look at the bandwidth congestion, one of the things, let me just zoom into that. The key thing is, when you're trying to put various things on Ethernet and it doesn't have prioritization, the key thing visually, this really struck me when I saw it, so I just used it here too. It doesn't have a way to say what's priority and assign where, what parts of the bandwidth are going to be used. So literally, this is taken off of some of the research that was being done as the demo was being developed by BE.services of that robot. We actually had just a standard LAN network set up at the show. We had video cameras so they could watch people walking by, and at the same time, that same system was actually controlling the robot and going through various switches and the TSN switches. But because we turned on the TSN side, you instantly see how you're dividing the traffic into the various axes. Some of the axes for the robot, it had multiple axes, so each one had its own channel where it was flowing through, and we had the video traffic as well. So it perfectly facilitates that. Also, when we did some measuring of the jitter, we're roughly in the plus or minus 5 microseconds for the jitter. So again, that's a focus on making sure that you have a reliable, connection stream going through. Now, at the same time, I was mentioning devices, so we, again, working with BE.services, so we jointly provide various already reference designs. So whether you're talking on TI Cetera or X number, a whole bunch of them. Actually, I have one of the developers from BE here, so if you have questions, you can ask later. But these are already ready. You can already start. It gives you a good starting point to say, hey, this is roughly the size, this is the type of compute power that we need for our application. You can see how it's done, and then it's a question of extending that, of how you're going to want to use it yourself for what you need. Okay, so as far as the professional services, and I borrowed the graphic from Peter, so thank you, the steps. So a key message is that when you're implementing UAFX, it's not just a one-time shot, it's more of a journey, because as you implement more functionality, it sort of extends what you do. But you do need to start off with some kind of minimum. So currently when we're talking about eFlex, the first 3 steps are what it covers, plus the ETSN portion that also brings in all the timing and everything else that I just talked about. So basically then you grow from that, and for example, safety being the one that was shown, sort of, once you have that TSN communications and you're extending it now for a particular application, that's what you do. But another important thing is that not everything is implemented at once. And just like in OPC UA, we have lots of optional features. Some are core, some are optional. In the TSN side, that's the same thing. So depending on the application that you're doing, you may or may not need everything that's shown, for example, in the staircase here, right, or the layers. But for the core, to have the communications, like I was showing, whether you're controlling robots or doing the synchronized, lights and discs spinning, whatever, and all moving together, that's already here, right? So you could move to that development stage very quickly. So whether then you want to do consulting or have consulting done, where they can help you with it, or just the training, or you could do it alone, again, with the toolkit, it just makes it more accessible. All right, short and sweet, that's hopefully. Thank you, guys.